Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout with Carolan. Terraform uses an infrastructure as code approach to provide effective, reusable, and safe infrastructure provisioning automation. Sean will show you how to get up and running quickly with Terraform on Azure. After the demo, we'll take live questions from the audience. I also want to note that this Hangout is recorded and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be just 15 minutes and then we'll allow up to 30 minutes afterward for questions. So with that, let's go ahead and get started. Take it away, Sean.
Thanks, Amanda. Welcome to the Beginner's Guide to Terraform on Azure. We'll have you provisioning your first application on Azure with Terraform in less than 15 minutes. If you're new to Terraform or Azure, this webinar is for you. And if you're a Terraform veteran, you might want to hang around because perhaps you'll learn a few new tricks. My name is Carolan, and I'm a solutions engineer with HashiCorp. I like building things. In my past life, I was a Linux system administrator, and one of my hobbies is video games. I really like to play games. And every modern video game has got a little tutorial level. So this is your tutorial level for Azure and Terraform. Learning a new skill can be scary and weird. Maybe you're not a programmer, but don't let that stop you. Terraform's not like learning C or Java. You don't need to be an expert software developer to take advantage of Terraform. So our goal today is to equip you with some basic skills and get you started on your journey with infrastructure as code. Once you've got some basic Terraform skills under your belt, this gets a lot easier. It's like learning any new language. The key is to get started with the basics and practice. What is Microsoft Azure? The Merriam-Webster dictionary defines Azure as bright blue in color, like a cloudless sky. So just imagine you're a majestic eagle soaring above the clouds. At least that's what the marketing team would like you to think, even though you might be sitting in a cubicle typing code. The second important thing on your mind, maybe, how do you pronounce Azure? I've heard a few different variations. So in US English, it sounds like Azure. UK English is more like Azure. And if you say it as a noun in UK English, it's Azure. And maybe if you speak Spanish, it might sound like Azure. I'm going to stick with the standard English pronunciation. That's how most folks at Microsoft seem to say it. They say Azure, like that. Now, however you pronounce Azure will probably depend on where you are in the world and which flavor of English is most popular there. So what can you build in Azure? We know it's a cloud. What sorts of things can you build in the cloud? Linux virtual machines. You may not know this, but Azure has a huge number of Linux workloads running on it. So maybe the most popular OS actually running in Azure. You can also run Windows virtual machines, containers, networks, databases, functions as a service, just about anything. The beauty of the cloud is that it allows organizations and companies to rent their infrastructure. Traditionally, if you wanted to run an application, you'd either need to build your own data center, or perhaps you'd lease some space from a data center provider. Then you buy a bunch of servers, install your operating system and applications on them, and configure your apps for use. Nowadays, most companies don't want to be in the business of running data centers. It's expensive, it's hard, it's not your primary goal as a business. Many companies struggle to run their data center. But guess what? Microsoft is really quite good at this. They have a ton of experience, huge teams of people to maintain all the hardware and network connectivity that you need. So you can simply rent your resources by the hour or even by the minute. This is pay-as-you-go computing that you use just like a utility. So you might imagine I have some faucets or knobs, and each one has a label: compute, network, and storage. Now I can go turn these faucets on as much as I need, run them as long as I want to, and then shut them off when I'm done using them. So this is the modern, cloud way of doing things. We can use what we need when we need to, and then shut it off when we're not using it. So it's very efficient. And Microsoft is able to leverage economies of scale and have huge numbers of machines in 50 different data centers all around the world that you can use anytime you need to. So what is Terraform? Terraform is a language and a tool that lets you quickly and easily provision your infrastructure into any cloud. Sometimes we call this infrastructure as code. So it's basically a way to describe the things you want to build in the cloud. I like to call it executable documentation. Terraform is very easy to learn. It's designed to be human and machine readable. And it's also very easy to test, share, reuse, and build as part of your automation. And it works across all major cloud providers. Let's jump in and do a live demo. I'm going to walk you through the process of building a very simple application in Azure. First, we'll go through the Azure portal and see how you might deploy a virtual machine manually. Then we'll take a peek at Azure Resource Manager template, and then we'll actually deploy our application using Terraform. So the first thing we want to do is log on to the Azure portal. If you don't have an account, you can easily sign up for one for free. Microsoft will actually give you $200 US dollars in Azure credits to use in your first 30 days. Or if you'd like an ongoing account that you can use for development anytime, you can sign up for the Visual Studio Dev Essentials program. And Microsoft will give you $25 a month in credit that you can use. So even if your company doesn't have an Azure account that you can play around in, you could sign up for a personal account and get to learn and know how to use Terraform on Azure. Now, once you've signed in, you'll see your landing page in the portal. One of the things I like about Azure is the ability to have custom dashboards that show different resources. So this is my Terraform and Azure Vault demo dashboard. And over here on the left side is the main navigation menu where we can build or view different types of cloud resources. So I pop that menu out, you could see all the different types of things you can look at and build in Azure. Now, suppose I want to build a virtual machine. I can use this handy little wizard here. Click the plus, and then let's say we want a Windows server. And then you get these steps and forms that you can fill in to describe what it is you'd like to build. So you might walk through and add in all of your settings and basically walk through this wizard. It looks like my password wasn't complex enough. And if you get through the whole process, at the end, Azure will spin up a VM and all of the other pieces that are required to run your VM for you. Easy, right? So you might be thinking to yourself at this point, why would I need Terraform when I already have this handy GUI here? Let's talk about complexity a bit. The Azure UI has actually hidden away most of the pieces that are required to stand up my VM. Here's a graph of all the parts that have to be configured just to get a single virtual machine running. So look how much complexity is involved. This is just to create one VM, mind you. When I'm using the GUI, I can stand up one or even a handful of machines pretty easily. But imagine if I had to create 100 of these, or if I had to create, other resources as well and connect them all together. Using the UI doesn't really scale that well. I could go through this process a dozen times, but it's not really practical. Plus, I might make mistakes. Humans make mistakes, and I, could make a typo here or select the wrong setting as I go through the GUI. So these manual processes quickly become burdensome the more complex my infrastructure needs are. All right, what about ARM templates? You might have heard of ARM templates. ARM stands for Azure Resource Manager. These ARM templates are basically pre-configured settings that allow you to define your Azure infrastructure. So it is a form of infrastructure as code. ARM templates are defined as JSON or JavaScript object notation. So that's what we're looking at right here. This is a JSON file. JSON is the de facto language of APIs. So when computers need to talk to one another across a network, they often use JSON formatted data. And the thing about JSON is it's great for computers, but not so friendly for humans to read and edit. Let me show you what I mean by that. We're going to play a little game called Fun with JSON. This also works with AWS CloudFormation and GCP Deployment Manager, by the way. All of them use JSON as the data format. So this is an example ARM template that I pulled from the Azure Quick Start repo. And let's see. So you'll notice that JSON has lots of commas here and curly braces. These are all required so that the computers that have to read this code know how to reconstruct the data that you want to use to build your infrastructure. So what I did was I took this template and dropped it into a JSON testing tool called JSON lint. And then I went through and removed a few random commas and curly braces. Now, every comma and every curly brace is required. JSON does not tolerate errors, and if you miss one or add an extra one, it won't work. It won't work at all. Everybody makes mistakes, and when you have 10,000 commas and curly braces to look after, it's inevitable you're going to forget one here and there. Maybe you add an extra character where it shouldn't be. I tried to fix this and gave up on it after about 10 minutes. I think I broke it beyond repair. At least I don't know where the missing comma is anymore. So I once had a nightmare. I was in this jungle and all of the vines were shaped like curly braces and there were thorns on the vines and they were poking me, and these thorns were all these commas. I call it the JSON jungle. It wasn't fun. Let's take a look at a side-by-side comparison of JSON versus Terraform. So just to compare these two. Here we want to define a simple local variable and give a custom name to a thing. So in JSON, here's the way you do that. I have a key here, and then on the right side, I've got 3 or 4 layers of braces and parentheses to concatenate my name along with this suffix nick. So I'm going to hop over to this dash nick is basically what I'm doing. And then below, you see the same thing in Terraform. It's much simpler and much more compact. Mentally, it's easier to deal with and fewer opportunities to make a mistake with the Terraform way. Here's another example of running a simple shell script with parameters. So in JSON, I have to take the command and then stick a space in, and then add a parameter, and then stick another space in. And so you get this long, complex command just to run a simple shell script. In Terraform, it's much simpler. I basically type the script almost exactly the way I would do it on the command line, using these variables here to fill in the correct variables for my IP and address prefix. So it's not uncommon to take, a JSON template, and if you convert it into Terraform, it could be less than half the amount of code, or even less, because it's much more efficient and easy to work with. So not to bash on JSON, it's efficient, it works great once it's in place. ARM templates work pretty well. It's when you have to edit them and change them a lot, this gets to be a little bit, troublesome and difficult. So those are some of the differences, different ways you can stand up machines in Azure. The first one that we went over was the GUI. So the GUI is pretty good for single machines or small groups of machines. The second way is to build or find an ARM template and maybe configure it to your use. And then the third way, which I'm about to show you, is using Terraform code. So let's go back to our Azure dashboard. And you might have seen this, or maybe not. There's a little button up here that launches what they call Cloud Shell. Azure Cloud Shell. Think of it like a mini workstation that travels with you. Whenever you log on, all of your files are there. And it comes pre-installed, pre-configured to work really well with Azure tools. So things like the Azure command line is pre-installed. I can do AZ commands. I also have Git. So if you're working with infrastructure as code and Git repos, Git is pre-installed. That's kind of nice. And Terraform is also pre-installed, already set up and ready to go for you. So let's go ahead and we're gonna clone a repo that contains some Terraform code with the Git command. And I'll crank the text size up a bit bigger here. I'm going to do a git clone. Oops. remember the name of the repo. Azure Terraform Beginners. So if you haven't used Git before, this command simply copies some code that lives on GitHub right here down into my Cloud Shell environment. So I run my clone command, and now I have a directory full of Terraform code. I'm going to cd into that directory. Now I can see there are a bunch of files in here. Anything that ends in a TF extension, like this file here, that's Terraform code. And then the other files are just there to support my Terraform code or provide some documentation. My next step is to copy my example file. If you want to follow along at home, you can do this in your own account. We're copying the example file to our own variables file that we can use. And then we're going to run this code command. This is a built-in text editor. Cloud Shell also includes VI, Emacs, and Nano, if you're comfortable with those. Code is kind of nice because it gives you a file browser here on the left, kind of a nice UI, and some great features. So we're going to open up our variables file. And there are a few variables we want to configure before we spin up our application. The first one is our resource group. So you might like to replace this with your name. And then for our host name, these need to be unique within a region. So if you're following along at home, change this to some random number here so that you don't collide with another number that was already taken. You can make this name most anything you want as long as it's a valid DNS name. So dashes are okay, probably not underscores. I would just stick with letters and numbers for now. So we'll give our app a name. Mine's called catapp99. And then the next variable is our location. Mine's set to Central US, but if I wanted to spin this up in a different region, I can get a list of regions with this command here. Oops. I'll just type it in. These are all the different places you can spin up Azure resources. Let's go ahead and check to see if the instance type that we want is available. So I'm going to copy this here, and we'll paste the command in. And let's just see if we can spin this up in, we're going to do West India today. If you get a result from this command, that means that the standard A0 instance is available there, and you can use that region to do this little workshop or demo. Okay, so I've configured my 3 variables. I'm going to save this file, so I can do Control S. And then I don't need the text editor anymore. So if you want to close, you can do that up here, or you can hit Control Q. And now I can start to run Terraform commands. The first command you're going to want to run is Terraform init. Terraform init. Terraform init gets our workspace ready, pulls in all of the plugins and modules that we need to build. So because we're building on Azure, it grabbed the Azure provider, the Azure RM provider, and it's ready to run. So this has been initialized. You only need to run Terraform plan once. The next, or Terraform init once, excuse me. The next step is to run Terraform plan. This is like a dry run. Terraform is now saying, here's what I would have built if you actually ran this. So it's like a test run to let you see what Terraform would do without actually changing anything. It all looks good. I have 7 new resources to add. I'm going to run Terraform apply. And you get one last chance to back out. Terraform should ask me now, are you sure you want to do this? And you could put the auto approve flag in too if you don't want to be asked yes or no. So this is our chance to confirm, yes, that really is what I'd like to do. Please go ahead and start building my infrastructure. So Terraform is off and running. If I want to watch my infrastructure being built in real time, I can hop over here to the resource groups. And let's filter by name so we can find mine. There's my resource group. And we can see what's been built so far. So we have a resource group, a virtual network, the public IP address, and security group so far have been built. And if we hit refresh, we should see some more things start to appear. There's my OS disk, and my virtual machine are coming up now. So Terraform is extremely efficient and fast. It's going to build these things in the correct order every single time, and I don't have to think too hard about how to set them up or name them properly. While this runs, let's go ahead and look at the Terraform code that built this, or that's building this now. I'll walk through it so you can kind of understand what we're building and how it works. For that, I will open another Cloud Shell. Or actually, we can just open the editor here. There we go. I'll try to make the text size a little bit bigger for you. All right, there we go. I mentioned earlier that anything that ends in TF is Terraform code. So I have a few TF files in here. Normally you'll see main, outputs, and variables. Each of these has a specific purpose, and it's not required, but this is the general practice that most people follow. Let's start with main. This is where all of our Terraform code lives. And I put a lot of comments in this file so you can make sense of what it's doing. This is our first resource. It's a resource group. So every Terraform resource has the same structure. First, we declare the thing we want to build, which is a resource, the type of resource, which we can find in the documentation, and then we give it a name. So that name is going to match what shows up in the portal, because that's not true. The name is here. This name refers to this resource group internally. So Terraform is going to use this one later on inside of my code. So with Azure, you have to have a resource group. Think of it as a container to hold all of your other resources. And you can manage resource groups as a whole. So everything within the resource group can be managed together. The next thing we build is a virtual network. So if you want to run a virtual machine, you need some kind of a network to run it on. This stanza sets up the network for us. And you'll notice some variables in here. So this name of the network was configured using a variable that we can define separately. And that way you can stand up lots of these and give them different names. We also are referring to other things like the resource group name. So this tells Terraform which resource group should this virtual network actually go in. Then we build a subnet to run our VMs in. So this is the subnet network space that we're gonna stick our virtual machine into. Once we have a resource group, a network, and a subnet, now we can put a VM onto it. And to allow access to our VM, we need a security group. This security group is allowing traffic to come into my VM on port 80. You can see port 80 here. And port 22, that's for SSH, in case I want to connect to the machine and run SSH commands. Now, every VM requires a network interface. This is what allows the machine to connect to the network. The beauty of this is that Terraform will let you know if you're missing any dependencies. So if I forgot to configure the network interface, or I did it wrong, Terraform will warn me and say, hey, you probably need to configure this. We've added a public IP address so we can see our web app on the internet. And then finally, we build our virtual machine. You can see it just finished building. So these variables all describe the host name, the location, what size of VM you'd like to build, storage config. And then down here, we're using a simple provisioner to set up our machine. Terraform supports several provisioners. In this case, we're using one called remote exec, and that's simply running a shell script on the remote machine to configure it. You can also use tools like Chef or Ansible or Puppet. There's several different provisioners that are supported by Terraform that you could use to configure your machine. So that's it. That's pretty much a simple template that you can use to get started. You could change this and adopt it to your own needs. And we stood up a little application in the West India region. This is our hello world, actually meow world with a cat. Now the code that set this up, it's very simple. It's just a shell script that lives in here. And if you'd like to change it or try different colors, you can adjust those here. And this is a kittens as a service API. So I wanted a different sized kitten. I could change the dimensions of the photo, save it, and then the next time I go ahead and provision this app using Terraform, I'll get a different website with my new settings configured because I changed the provisioner. Now let's say I'm done for the day. I'd like to clean up. You don't have to go through the UI and find all your resources. Terraform actually makes it very easy to clean up after yourself. So you can do a Terraform destroy. And now Terraform is going to go through and find all of the things it built before and delete them for you. If I come back in here, I should see the reverse now happen. These resources are going to start disappearing from the UI. Now you might be curious, how does Terraform keep track of all of what it built? So for that, there's a thing called a state file. And you'll see that state file right here. This is how Terraform knows what it built and what to delete or change if you decided to change anything. The nice thing about using Azure Cloud Shell for this is that your state file gets stored safely in the cloud. It's not on your laptop, so that if you did some work in Azure Cloud Shell and then came back later, your state file is safe and you can update or delete your resources as you need to. So we'll just let that go ahead and run. And that brings us to the end of the Terraform for Beginners on Azure demo. What questions do you have for us?
Okay, Sean, we have a few questions that have been coming in. And so yes, if anyone has questions, please feel free to submit them. So Sean, first question, someone's saying that they understand that the ARM templates such as JSON have their own complexities and issues. So what they're wondering is, Terraform probably similarly has some sort of complexities and issues. What are some of those for Terraform? Can you kind of highlight some of those?
Okay. So what are some of the challenges that you'll run into with Terraform as compared to JSON? I could do a quick comparison, sure. JSON at its heart is very simple. It is simply a data structure. So the rules are really simple. You've got these key value pairs and everything has to match correctly. JSON is sort of universal. So any computer, API practically can read JSON data. So the bar to entry is pretty low. There are quite a few quick start templates here on the Azure GitHub portal. Actually deleted the S. So you can download those here. But as we mentioned, working with JSON and wrangling it can be troublesome, especially if you have to build logic and things like that into your code. Now, Terraform is not magic. There are some challenges with Terraform as well. The first is just getting over learning a new language. Many folks I talk to have heard of Terraform, and they say, yeah, I know I should look at that, but I just don't have time, right? Or I don't want to learn a new programming language. That looks hard. There are different reasons. Or my company doesn't use that, and I could use it, but no one else will be able to. In particular, I don't think learning Terraform is very hard. We have lots of quick start tutorials like the one I just showed you. Um, where it gets more challenging is when you're trying to build something non-standard or something that's not supported right out of the box. And learning how to put the different pieces of Terraform together, in the correct way, that can be a little bit challenging. But it's definitely overall an easier and less painful process than trying to configure the same thing in JSON. So not without its challenges. The advantage, though, is you've learned this new skill that works on any cloud platform. The list of Terraform providers, provisioners is huge. Not provisioners, providers rather. So there are a giant number of different things you can configure using Terraform. Here's a list, most of them. There are many more. You can even build your own if you find that something's not meeting your needs. So if part of your infrastructure lives in Azure, but you need to configure some GitHub stuff and maybe Datadog as well, you can build all of it with Terraform. It's a multi-platform language, so that if someday you decide to try a different cloud or use one of these services, guess what? You don't have to start from ground zero. You can actually use the Terraform that you already know and are comfortable with and build your infrastructure on any of these different providers. So hopefully that helps answer the question a little bit. Mainly, I encourage you to try it. Yeah, take it for a spin. You can even copy our examples and just adjust them a bit so you don't have to write your own from scratch.
Perfect. Thanks, Sean. Okay, next question, kind of going back. So someone's asking, how can Terraform templates and state files be managed in a larger organization?
That's an excellent question. There's a couple ways you can do that. With open source Terraform, you can store that state file online. So some people will use a database or like an S3 or S3 compatible storage for that. That works well with small teams who are pretty talented and able to build their own, kind of scaffolding around the tool. If you have a larger team or organization and you'd like more control, we do have an enterprise version. It's Terraform Enterprise, and that handles your state files for you. So they'll be stored on a server, the Terraform Enterprise server, and you don't have to think too hard about managing the state file because it's built into the product.
Cool. Okay, and questions are flowing in. So Sean, next question, is Terraform binary common for all the cloud providers? Can we have different providers like AWS, Azure, and GCP in a single Terraform file?
You can. You can. In fact, many Terraform modules and code will have 5 or 6 providers built in. And, providers are very flexible. There's even a provider that generates random numbers or letters. So you pull in the providers you need, write the code you want, and build your hybrid infrastructure with ease.
Okay. And next question. So someone's saying, if we've already invested a lot of time in building our standardized ARM templates, are there any benefits to learning and then recreating them in Terraform when we are currently on a single cloud shop?
Probably not. Honestly speaking, if you spent all this time and trouble writing ARM templates and they're working for you, I wouldn't recommend tearing them apart and rebuilding them. What I would recommend, though, is that you augment your ARM templates with Terraform to build the things that ARM doesn't support. So most applications do not live in a single cloud. You may have external dependencies or things that are not living within Azure. And so Microsoft has recently added the ability for you to run Terraform from within an ARM template. So you get the best of both worlds in this case. You can have your ARM template build everything it possibly can inside of Azure, and then use Terraform to cover that last mile. Maybe there's something outside of the cloud that you need to configure. Maybe it's on GitHub, for example. You could do that using Terraform in conjunction with your existing ARM templates.
Okay, so now someone's wondering, Sean, if we need to move from one cloud provider to another within Terraform, how easy is the migration within Terraform? They're saying the provider-specific syntax.
Understood. It's not magic. I wish I could wave a magic wand and automatically move your, cloud Terraform config from one cloud to another. But the good news is we have some things that make it easier for you. So think about your application, and there are going to be certain things that are common on whatever cloud you run your app on. Think about chef recipes or maybe Ansible code or the applications running on the machines. It doesn't matter what cloud you're running on. That stuff is going to be all exactly the same. So what you want to do is separate out the things that are common or shared across multiple clouds. Maybe those are all your setup scripts, or perhaps they might be a chef cookbook or an Ansible playbook or Puppet module. Take all that stuff and put it in a shared folder. And now you're going to have other folders for each cloud. So each directory, say you have one for Azure, you might have one for AWS or GCP. And inside each of those, we'll have slightly different Terraform code for each platform. Now, it's still Terraform. You can still read it and write it the same way, but it's going to vary slightly because each cloud provider is different. They provide a different API, and each one of them has different settings and a different way to authenticate. And so it gives you an easy way to kind of write code that will work on each cloud provider, but without having to rewrite all of the stuff that's common across all three. And then you can store all of that code in your source repo and be able to easily provision your app on multiple clouds.
Okay. So now someone's wondering, Sean, can you explain the main.tf and state files? What's the scope of the state file? What happens if the files get deleted?
Yeah, let's talk about that. That's a great question. I'm going to pop my Cloud Shell back open here. Here it is. Okay. It's still warming up. There we go. All right. So inside a Terraform repo or folder, you'll typically find one or more TF files. And the way Terraform works is it just looks in this directory. Anything that ends in TF is going to get run. So I could have named this, webapp.tf, for example, or anything I wanted to. Sort of best practice is main outputs and variables. So in this case, it's a simple app. I just went with one file called main.tf. But I could have broken this up. If I wanted to put the network stuff into its own file, for example, you can just easily copy it all out. Okay, so we'll take that out of there and we'll make a new file. Sorry, I'm still getting used to this editor. You get the idea. I make a new file and paste the code in there. It will run just as well. So Terraform is smart enough to gather up all of the TF files and put them in the correct order and run them for you. Now the second file, which I didn't show you earlier, is called outputs.tf. This is the file you use that exposes info at the end of the Terraform run. You might want to use this to give some instructions to the next person who runs Terraform apply. And then there's variables. This is where you define the buttons and knobs that you want your users to have access to. So anything that someone might want to change to adjust to their own environment would go into a variable. Now there's another file here called tf_state. And you can see since I deleted everything, it's pretty empty. There aren't any resources. It's basically an empty state file right now. This state file is important. If you build something with Terraform, it is the snapshot, it's the last known record of what Terraform built. The reason you need this is in case you decide to change any of that stuff, or if you want to delete it later, Terraform needs to know with certainty that it's deleting the correct thing or changing the correct thing. It's important to protect that state file. So we make you a backup just in case you accidentally delete it. There's a backup here. We do recommend taking care of this file, and generally on developer environments you can store it on your laptop, but if you're doing anything serious with Terraform, put that state file somewhere it's unlikely to get deleted or accidentally corrupted. Take backups of it, because it is the snapshot or the record of what you've built in Terraform.
Okay. And so next, Sean, if Terraform can also configure like installing applications into machines, why use Ansible? How does Terraform differentiate from Ansible and Chef?
That's a fantastic question. So Ansible and Chef are both great tools for doing config management. And what I mean by that is you have a server with an OS on it. You need to get your middleware and your applications and your OS security settings. All of that stuff has to be configured before you can use that machine. Chef, Ansible, and Puppet all really shine. They all do really well at that type of configuration management. Where those tools fall a little bit short is configuring things that are outside of the world of the OS. So networks and functions as a service and subnets and security groups and so on and so forth. All of those other things that the OS needs to run, Terraform is really great at building that stuff. What Terraform doesn't aim to be is a config management tool. So we do offer you a few different provisioners. A list of them. You can use Bash, you can use Ansible, you can use Chef, but Terraform is not built for doing config management. We give you a simple way to run other tools that will handle that. And quite frankly, there are lots of great tools that do config management. So here's the Chef one. I might have a Chef cookbook and use that to configure my OS. Or if I've got a simple shell script, I can use that as well. So the answer is pretty simple. If you need to do a lot of complex config management, you should use Ansible. If you're just putting a few files in place, you could probably get by with the shell script. But in either case, you pick a provisioner that's appropriate to the task at hand, and Terraform is happy to run that for you.
Okay. So next question, can you add a front-end layer to Terraform, such as Jenkins or Rundeck, to enable non-developers to deploy infrastructure by simply filling out variables in a web portal?
You absolutely can. Many users use CI/CD tools like Jenkins or Circle CI. What you'd want to do is just give a system user the ability to run Terraform, and then your CI tool can kick off Terraform runs for you. Now, if you want to make that a little easier, Terraform Enterprise supports API-driven workflows, so that now instead of having Jenkins run a shell script, it's a bit cleaner. You're having Jenkins interact with an API that gives you consistent feedback and results.
Okay. So now, Sean, someone's saying, we're about to start using Terraform for our Azure infrastructure at work. What are some of the difficulties when working with Terraform as a team? So do you maybe want to just kind of touch on some of the benefits of enterprise over OSS in that situation?
Yeah, definitely happy to. Terraform Enterprise is purpose-built for teams. So first of all, you don't want to have to manage everybody's authentication and being able to log on to the system. Terraform Enterprise supports SAML, so you can log in with your Active Directory credentials and already have your workspaces and environments set up and ready to go for you. We can also add restrictions so that people can only see the Terraform code they need to see. A developer team might have their own set of workspaces where they collaborate together. And what you would do is commit your code to your Git repo. Someone would do code review here inside the Git repo, and then you do a pull request, right? And so there's a lot more process now that is easy to do because you just automated basically infrastructure as code. So developers can, at the same time, multiple people could be working on this code repo and submitting all their changes. And then those changes are going to gracefully flow into Terraform Enterprise and all be merged into the same infrastructure without people kind of stepping on each other's toes or building more than one of something. So it's designed to streamline the process of multiple users collaborating on code and kind of streamlining that to make sure it's smooth and efficient.
Okay. So, and we have a lot of questions, so we aren't going to get through all of them, but we'll do a few more.
Okay.
So, Sean, someone's asking, what developer tools would you recommend to make writing Terraform scripts easier for beginners, such as syntax checking, syntax suggestions, etc.?
I love this question. This is Visual Studio Code. So it's a text editor. It's been created by Microsoft. I'm a huge fan. It works on Mac, Linux, and Windows, and it comes with all these great plugins. So the two plugins I would recommend for a beginner to Terraform on Azure, you just come up here and search for Terraform. This one is fantastic by Mikhail Olenfalk. It has 500,000 downloads. There's a good reason for that. This is what gives you all the pretty syntax highlighting and formatting and all that good stuff, so that if I put too many spaces in here, it can actually format and automatically clean up my code for me, or tell me that I'm missing a bracket. It'll be able to throw errors and highlight the place where I made a mistake. Another great one is the Azure Terraform extension right here. And so you can even connect your Visual Studio Code directly up to Azure Cloud Shell. And it's sort of neat because it copies all of your code into your Cloud Shell and lets you run Terraform commands. This is a great one. You can even run commands from the UI here. So you can see you got all of your Azure stuff built into the GUI. Git support is built in too. So that's a really neat feature as well. Your source code settings will automatically be picked up, and Visual Studio Code will tell you what branch you're on. It will let you make changes. You can do commits, and you can do all sorts of things with your source code provider right from within the text editor. Now, there's one more feature that I really dig about Visual Studio Code. It's got a built-in terminal. So you can pop a terminal open anytime you need to with the Control-J command. Supports PowerShell or Bash. If you're running Linux, you can run Bash here. And so you can edit your code right here in the top, and then you can immediately run your code and test your code right here in the little bottom shell here. So that's what I'd recommend for someone getting started, wants to have some basic plugins and highlighting. If you can't or aren't able to install software on your local machine, just use Cloud Shell. It's also got a great built-in text editor, and Terraform is pre-installed for you. So it's never been easier to get started with Terraform on Azure.
Awesome. Thank you, Sean. Okay, I think we'll do two more questions. Someone wants to know, how do they protect sensitive data, such as secrets, in the Terraform state files?
Excellent question. As you might have noticed, if you're a veteran Terraform user, sometimes secrets end up being stored in a state file. It's hard to avoid that because as part of building infrastructure, you need to store secrets. So if you're doing Terraform open source, protect the machine where you're running your Terraform commands. You want to lock that machine down and make sure that it's safe, right? And that unauthorized people can't log on and read those files. You can also use Terraform Enterprise, and we will encrypt the state file for you, so it's encrypted at rest. Now, of course, if you open it and look inside, you may see those secrets, but we do our best to kind of protect those in the Terraform Enterprise UI.
Okay, thank you. And so now someone's saying they manage their infrastructure with Terraform and the creation of the containers and the applications on that. How should they manage multiple Terraform state files?
Multiple Terraform state files. Again, I hate to beat this drum, but I would again recommend Terraform Enterprise. So what you can do with Terraform Enterprise is have a state file that's stored remotely, and then you can have another workspace referencing that state file. And so it's nice because you can chain together different workspaces and have them all work together in harmony. Another option for you would be to modularize things. As you build, you break things into modules so that the common stuff that's shared across your multiple Terraform workspaces can all be put into a module, so you're not repeating yourself.
Okay, thank you. Okay, and this will be the final question, Sean. So
okay.
Someone's saying, how do they make changes to existing infrastructure via Terraform existing infrastructure that they built manually?
Great question. Terraform comes with a lot of handy subcommands. So I kind of seem to have lost my Cloud Shell. I'll go ahead and restart it. Just show you the command really quick so you can see it. Wake up, little Cloud Shell. Okay, here it comes, I think. I'll just describe it to you. It's the Terraform taint command. So if you want to force a rebuild of parts or even all of your infrastructure, you run this command called Terraform taint, and that will mark any of the resources in your state file as tainted. And so the next time Terraform runs, it will know, hey, this thing needs to be rebuilt. So that's how you can rebuild part of your infrastructure.
Okay.
Also, just to add on to that real quick, if you change any of the code, Terraform is smart enough to know what to rebuild for you. So just running Terraform apply again will actually apply any changes that you made.
Okay. And Sean, someone asked if there's going to be a deep dive session conducted following this. So we'll see if maybe we can get another session on Sean's calendar in the future of a part 2 to this. People have been very...
Okay.
I think it's been a great session. So that's going to wrap up Q&A for us today. Thank you so much, Sean, for powering through all of those. And I hope everyone enjoyed today's Hangout and has a better understanding of how to use Terraform on Azure. Thanks for joining us, and a big thank you to Sean for his time today. As I mentioned at the beginning, this Hangout was recorded, and we will make the recording available on our website after processing. I will send an email to everyone who registered with that recording link. So that wraps things up for us. Have a great day, everyone. Goodbye.